In my first iteration of the Bargraphs used on the Voight Kampff machine, I had built these two separate boards, and I was using this commercial Bargraph display for the Bargraph below the two smaller screens on the Voight Kampff machine. And then I was using this board that I had put together to control the bar graph over the main screen. This little one has 10 LEDs. This one had 12, 10 green and 2 red. Obviously I've taken those out of here. My only issue was I took them out of there and saved them and then proceeded to lose them. So on this newer iteration, the bar graph that I have here, and hopefully we can get a little bit of a close-up on it and keep the light in there. I wasn't using, even though they look like it, well, they are now rectangular LEDs initially, because I could not find the original ones. I started with a bunch of 5mm RGB LEDs that I've got on my bench, and I had to take these guys and grind down the sides to fit this array here. So that's something you can do in a pinch. That's not something I plan on actually putting in the machine, but I wanted to actually get a working prototype going. So if anybody wanted to look extra close on these, you can see they're not all quite the same size, but it does get the sort of proof of concept here. Anyway, my initial design was to utilize what is it, the HC595 shift registers for the 12 LED display above the main monitors, and that worked quite well. And then for the smaller one below the smaller monitors, I was using a 4017 decade counter. So above the main one, or above the main monitor, I was using 2 shift registers, and the smaller monitors I was using a decade counter. And both these I was planning to interface with a ATtiny 85 microcontroller, so little 8-pin package here. But I finally, while working with all this stuff, I realized the part count was a little too high for all this. As you can see here, this needs 12 additional resistors. We have 2 chips, and that's not even counting the additional microcontroller chip, which was to go here. And then for this array, it's only 2 resistors, but we have those 2, another chip before we have the display. And I wanted to try to simplify this. In addition, since this was using a decade counter and this is using a shift register, I had basically needed to use different communication going to each of these. And again, just trying to simplify things and decrease part count here. So what I have decided now, and these are the same arrays, LED arrays or bar graphs that I was using initially, but and both of these are just hand fabricated, 3D printing, and so on. But for this setup, while it looks pretty crazy with all the jumper wires, well, all we have the 2 arrays, 1 microcontroller. I'm fairly certain I could use an AT1085 here, or to make it simpler, I could use one of the Adafruit trinkets, which is basically utilizing an AT1085 with some peripheral components to make it a little bit easier to interface. But regardless, all we have here is you have the 2 arrays, the connections. We only have 1 external resistor and 1 chip to control both. So much fewer parts. Yes, these chips are a bit more expensive, depending on how many you're buying. For the for the dip version like this, through hole, I think maybe $2 for it. The LEDs would be the same cost. The microcontroller, same cost. Resistor, it's only 1, so pretty minimal. And like I said, while it looks like there's a ton of connections here, and there are, it's actually no more than my original, workup of this. And the advantage is many fewer parts, so costs less, easier to put together, and simpler communication. So, well, I hope you guys like this. Thanks.